Hello, everybody. There we go. Here we are, 9.2, solving systems by elimination. So last time we did substitution and now elimination. I've typed some notes for you and I'll just kind of go over it and explain my thinking here. So there's kind of two ways to do the first step. So you can either make your x's or your y's the same. So make them both into a 4x and a 4x, for example, or an x and an x, for example, or a 3y and a 3y or whatever. And then you can subtract one of your linear relations from the other. Or you can make your x's and y's the same coefficient, but with opposite signs. So 2x and negative 2x, and then add them together. And that's how you're going to eliminate. You'll eliminate that one, and then you'll be able to solve for the other variable. So you can take either of those first steps, and you might use one or the other depending on the way the linear equations show up. And then the next part looks the same for either way. Then you solve for the remaining variable, substitute the variable into one of the original equation, and there we go. Solve for the other variable, and then check your answer. So let's have a look, and we can decide which of these kind of first two steps we want to do, and I can show you what they each look like. In a way, the adding might be easier, but we'll see. So here, solve using elimination. We could do either here. We have our x's are both positive x's, and here we have a positive y and we have a negative y. So I might choose this one over here and add them together. So if I draw a line like this, zoom down, and then we added these together. If I had an x plus an x, I'd have 2x. If I have a positive y plus a negative y, that's now gone. That's like eliminated. And that would equal 4 plus 10 equals 14. And now we can solve for the x, divide by 2, and x equals 7. Okay, great. And now we can substitute our 7 back into either of our original equations and solve. So we can say, 7 plus y equals 4. And then let's solve by subtracting. Where we want to go? We want to take away 7 from each side. And we get that y equals negative 3. So now we have that x equals 7 and y equals negative 3. And we can check, is it true? Let's look at our original equations. Is it true that 7 plus negative 3 equals 4? Yes. Is it true that 7 subtract negative 3, so 7 plus 3 essentially, does that equal 10? Yes. So you can be certain that those are true. Let me just show that anyways. Let's do 7 minus negative 3. Does that equal 10? And then yes, 10 does equal 10. So we confirmed that that is correct. So that's it. I mean, that's solving by elimination, and we'll do a few more examples, and I'll show you some of the kind of curveballs they try to throw you or the ways that it could look different. And I did that when I had opposite signs, so I added to eliminate those. Here, okay, so here we have a 4x and a 4x. They are the same. And we can now minus to get rid of our 4x's. So we have 4x's. We want to subtract the 4x's to eliminate them. So that gets rid of that. And here's the kind of tricky part. Now we have a negative 5y subtract a negative y, which is like adding a positive. So we're going to end up with minus 4y left over. And that's going to equal negative 28 subtract 4 is going to give us a negative 32. So it's a little bit harder to do, I think, the subtracting, but either way works. And but I'll show you, if you really hate the subtracting, what you can do. So divide by negative 4, divide by negative 4, and we get that y equals a positive 8. Okay, and now we can substitute it back into either of our original equations. Maybe I will do our second one, that 4x subtract 8 equals 4. Now let's add 8 to each side, and we get that 4x equals 12. And we can now divide by 4, and we get that x equals 3. Okay, and now let's confirm. We can use either of the equations. Maybe let's use our top one. So 4 times 3 subtract 5 times 8 should equal negative 28 if we've done that correctly. So is it true that 4 times 3 subtract 5 times 8 equals negative 28? So is it true that 12 subtract 40 equals negative 28? And I would say yes, it is true that 12 subtract 40 equals 28. So you confirm that we did it correct. Okay, one thing that we can do, and maybe I'll just point it out now before we scroll down. One thing that you could do if you really hate subtracting it is multiply this entire thing by -1. So this could become a -4, a positive y, and a -4, and then you can add them. So you can do that if you really hate the idea of subtracting them. Okay, these ones here, we don't kind of have a tidy way to start, and I'll show you what we do when we have that. So we can change the look of this by multiplying each of our terms by the same number. So if we want to make this y into a 2y, we could multiply the y, the x, and the 5 all by 2. And I'll show you that part, and I'll show you another option. So we can multiply this side by 2, and this side by 2. So we get, 10 equals 2x plus 2y. And then we can subtract them. I'll show you what that looks like. So if we have 2y, subtract 2y, that's gone. 6x, should show that we're subtracting. Subtract 2x equals 4x. And then 6 subtract 10 equals -4. And then we can divide by 4, and get that x equals -1. Okay. And we could have also, from the beginning, let me just draw it again right here, 5 equals x plus y. We could have also multiplied them all by -2. So you can multiply by -2 if you want to do the adding method. So then we would get -10 equals -2x, subtract 2y. And then if we want to add it to our other one, we would have 2 positive 2y plus -2y gives us 0. 6x plus -2x gives us 4x. And 6 plus -10 gives us -4x. So we still end up there, but maybe you like that a little bit better. And now let's do a step when we substitute. I'll just use our kind of simpler of the two equations. So we have this idea that -1 plus y equals 5. Let me do a different color. So I've just taken our original equation right here. Let's do blue. And I'll do it on the same, so it looks the same. -1, there we go, plus y. And now we can add 1 to each side, and we get that y equals 6. And now let's just confirm, is it true that, maybe let's do it in the top one, that 6 times -1 plus 2 times 6 equals 6? Is it true that -6 plus 12 equals 6? And I would say that yes, that is true. The -6 plus 12 does equal a positive 6, and you can be confirmed that you did it correctly. Now let's look at our last one. So again, nothing that really lines up. We'll need to multiply them all by the same number. And it looks like we'll have to do that to both. It can't just simply go from 2 to 3 or from 3 to 4, so we need to multiply each. And you could, if you like to add or subtract, think about, do you want to add it by, times it by a negative number or a positive number? You just need to do the same thing to each term. Remember, you do to one side, you have to do to the other, and you have to do it to the entire side. So let's go to 6, I guess, to change this 2 into a 6. I'm going to multiply this whole thing by 3. Each side by 3, let's say. So multiply this by 3 and multiply this by 3. And I need to multiply the top by 2. So multiply this whole side by 2 and multiply this side by 2. So what we get from that is we'll have 8x plus 6y equals 2. And then we'll have 9x plus 6y equals 6. So I just did the 3 times the 3x, 9x, 3 times the 2y, 6y, and 3 times 2 is 6. I did the 2 times the 4x, 8x. I did the 2 times the 3y, 6y, and 1 times 2 is 2. And now I have they're the same, so I'm going to subtract them. And now we have 8 subtract 9. She leaves us with negative 1x. These cancel out, and 2 subtract 6 equals negative 4. Then we divide by negative 1, divide by negative 1, and x equals 4. There's that one. And then we can substitute it into these ones. I might substitute it into one of the originals. Usually they have smaller numbers, and maybe that's a little bit easier to deal with. So let's go 3 times 4 plus 2y equals 2. So then we have 12 plus 2y equals 2. Let's subtract 12 from each side. That's gone, and now 2y equals negative 10. And we divide by 2. Divide by 2, we get the y equals negative 5. And now we can use either of our original equations to check. So is it true that 4 times 4 plus 3 times negative 5 equals 1? So is that true that 16 plus negative 15 equals 1? And I would say that yes, that is true. So there you have it. Kind of play around with it. You might want to use either method. Maybe you want to stick with exactly one method that works best for you. I just wanted to show you both. And thank you so much. I'll let you know what textbook questions I'd like you to do.